Now, what about LMC modifier? What if we apply LMC modifier with position control? For example, if we apply LMC, L and circle, with position tolerance 0.5 mm, so it just reversed to MMC modifier. It means the 0.5 mm position tolerance applied when shaft is at its LMC size, say 19 mm. And as the shaft size increased towards MMC 21 mm, the allowable position deviation will increase. This means, if the shaft is at 19 mm, the position tolerance is 0.5 mm. If the shaft diameter is 20 mm, the position deviation could be 1.5 mm. If the shaft diameter is at 21 mm at MMC, the allowable position deviation would be 2.5 mm. But this doesn't make any sense for most of assembly condition. In assemblies, if the part size is towards MMC, the position deviation should be smaller to ensure the good fit. Otherwise, part wouldn't fit correctly. Therefore, LMC is generally not used for the assembly condition. Instead, we use LMC modifier when we maintain a thin wall thickness. And at the same time, we're allowing the bonus tolerance. What I mean to say is, let's say we have a nylon block with a hole near its edge. And hole has size tolerance 20 mm plus or minus 1 mm. And its position tolerance is 0.5 mm relative to datum A, B and C. This face is datum A. So the wall thickness is very thin. And let's say we need to ensure that it doesn't go below 2 mm. If the hole size increased to its maximum, let's say 21 mm at LMC, even with the maximum position deviation 0.5 mm. So to ensure this, we can specify a basic dimension from datum A, which would be 2 mm, the wall thickness, plus the radius of this hole at LMC, which is 21 divided by 2, 10.5 mm, plus the radius of position tolerance diameter, 0.5 mm, divided by 2, 0.25, say 12.75 mm. So if the hole size is at 21 mm at LMC, the position tolerance is 0.5 mm, and the wall thickness is maintained at 2 mm. If the hole size decreases to 20.5 mm, moving towards MMC, the position tolerance remains 0.5 mm, but wall thickness now increased to 2.25 mm. If the hole size becomes 20 mm, the position tolerance will be still 0.5 mm, and the wall thickness further increased to 2.5 mm. However, the goal is only ensure that wall thickness does not fall below 2 mm. And this is where the LMC modifiers comes in handy. By applying the LMC modifier, indicated by L and circle, to the position tolerance, the hole can deviate more from its nominal position as the size decreases towards the MMC. For example, if the hole is 21 mm at LMC, the position deviation allowance is 0.5 mm, maintaining 2 mm wall thickness. If the hole size reduced to 20 mm, it's moving towards MMC, the bonus tolerance will be LMC minus actual size, 21 minus 20, 1 mm. Meaning, the total allowable position deviation becomes 1.5 mm, while still maintaining the 2 mm wall thickness. If the hole size is at smallest size, let's say 19 mm at MMC, the bonus tolerance is maximized to 2.5 mm, but again, 2 mm wall thickness is maintained. So using the LMC modifier ensures that even the hole size decreases, giving bonus tolerance, but the wall thickness requirement is never compromised, providing the flexibility in manufacturing while preventing the part integrity. So this is it for this video. If you have any doubt or any question, please let me know and comment. The next lesson should be on your screen, or you can check the description. The next lesson should be on your screen, or you can check the description. Thank you so much for watching.